Okay, good day, people. I would like to talk about Docker, the use of Docker for Perl people. Some people know me as El Che of NXIDM on IRC, on Twitter, or whatever. I'm also the dev room manager. We have kind of a schedule problem last time, so that's last minute, so that's why I'm here. A little about me. I work at the Competence Center of Information Security at the University of Leuven, and we do stuff related to security, to identity, to authentication, authorization, and stuff like that. So I would like to start with a kind of controversial question. So what kind of problem does Docker solve for Perl? And a typical reaction would be, what problem? Do we have a problem? And it's true that in Perl, like we had cpan for like ages, you know, before the people with beer were born. We have a very nice testing culture. We have a very nice community. We're great at writing tools. So it's very easy to be cozy in your Perl environment because it's very nice. But if we rephrase the question a little differently, we may get another answer. So if we ask the question, how do we deploy our programs now in 2017, we get a lot of different answers. You know, there's more than one way to do it. Some people use cpan or Ceph in a remote machine. I hope no one here works like that, but everywhere I've worked, I've seen people doing that on production machines. Some people use Rakudo Brew or Perl Brew to use their own Perl and not use system Perl. Some people use Cartoon to pin the dependencies. Some people use local leap. Flatpacker, very nice if your application is Perl only, so you can just make a one file, so you don't need to have this dependency tree. Mini cpan, dark cpan. Some people just create an archive and put it on the server. Some more sysadmin type people will create an OS dependent package, like a Debian package of an RPM. The same kind of people will probably use a configuration management tool like Puppet, like Salt, like Rix, like Sparrow Do. And if we are honest with ourselves, we must acknowledge that it can be a little fragile at times. When you're in full control of your environment, there are very nice tools. But when you're in kind of a bigger environment where it's a separation of responsibility, where you have some people like the Linux admins being responsible for the OS and updates, and you have application people being responsible for the application. Maybe they will do an update and your application is not well tested and it will break. If you are working on the cloud, when you need a really fast switch of environment, compiling stuff will take a long time, so it's not always the best solution. So if we look at other examples, if we look over the fence into other communities that kind of work around this problem, we see that it's not that easy. If we take Java by example, Java is great in this regard because in Java you put everything in a jar, you put the jar in the machine, you feed it to the JVM and it runs. It will load probably, I don't know, 50,000 classes without exaggeration, but it will run. It's great. But even then, you will meet class path hell when you have the same library with two versions on different paths. Your application will run, but it will explode along the way. So even then, if you go to Go, also a very nice language, when you do a static compilation of your program, when you add all the dependencies to your binary, you take the small file, you put it on the server, you run it, it's fantastic, it's fast, there's no VM. But even then, if you have a security problem in one of your libraries, you need to track down all those small binaries everywhere, and that's not easy if you don't have the infrastructure for it, because programs tend to outlive the programmer. I've heard from some colleagues where I worked like 10 years ago, they're still using a proof of concept I wrote, and the program start from this is a proof of concept in capital, they still use it. I don't think they even have the source, so that's a little difficult. So if we look at great example of other communities like Java and Go, we realize that deploying is only half of the question. And the real question in my eyes is, how do we integrate with an ecosystem that is no longer language-centric? And what do I mean by that? I mean that the future is API-centric. So you don't care that much about the language, you care about the API, you care about integrating stuff together. And even more, I could say that the present already is. If you're working within a DevOps teams, when you have a lot of people from different backgrounds, you have operation people, sysadmin people that they have their own tooling, you have developers that maybe have their own tooling, and if you work with people of different background, that means different languages, different frameworks, so you're already mixing stuff there. If you work with a cloud, when it's very important to be able to switch from one cloud provider to the other, when it's very important to be able to bring your instances up, it's very important that you have the best tool for the job. And this is a good thing, because it's very possible nowadays that the best tool for the job is not written in Perl. It could be written in Java, in Go, in Ruby, doesn't matter, because you still get the best tool for the job. So you can integrate stuff together. Well, back to Docker. A typical question is it here to stay? Is it a hype? Because if you've been around for some years in IT, you know, things come, things go, things come back slightly different. So that's a very good question. And the same people that would say, we had cpan for like 20 years, they would say, yeah, but we already have VM. What's new? So a VM, a virtual machine, the idea behind it is to fully integrate a discrete environment, to have a full operating system. That also means that you need to fully administer an operating system. Like you used to have one big physical machine, and now you have one physical machine with 10 VMs. You need a lot more work to keep that up to date, to keep it secure, to create users, and so on. And most importantly, a VM and a container are not at odds. They can work together. It's a very valid scenario to have a VM and to run containers on that. Maybe because you standardize around a VM, you can deploy them and provision them very quickly, or maybe because of security, you don't want your containers to share the same kernel. There are a lot of valid reasons to do that. Well, after this introduction, I would like to answer the question, what is Docker? Because I'm talking about Docker, but I haven't explained it yet. So if I'm forced to summarize it in one word, I said it already, it's a container. And the same people that said, yeah, cpan, yeah, VM, they would say container. We have been doing that forever. Me, myself, I've been doing that 2005 on Solaris Zones. I've probably migrated hundreds of physical machines to Solaris Zones. It was fun. You had CTVS. You could copy your container through SSH to another machine. It was a lot of fun. People working on IX probably 10 years before that. But it's not the same thing. So what's different, again, is the API. So Docker gives you an API to integrate it with other stuff. So if we redefine what a container is nowadays, of course, it's an application, it's self-contained. That's kind of the definition of a container. But the most important part is it's portable. So you work at your workstation on the same container, on the same binaries as on the production server, as the same thing that the customer has. So it's portable. You move stuff around and you move the same thing. You don't need to recreate everything and then test for the differences. So container, because of this, have a really huge impact on how we develop, how we distribute, and how we run software. So as a developer, it's priceless to be able to develop on the same environment as the production machine, because it's always the battle between sysadmins and developers. Yeah, it runs on my laptop. It doesn't run on the production server, or if it's too slow, whatever. So you will develop differently because you can have the full stack, all the different services on your laptop. You can distribute it within your company, test quality production. You just move the same thing on a new environment. You can push it to a client, exactly the same thing as you're having on your laptop. And it's also a very standard way to run software. You don't care if they use SUSE, of Fedora, of Debian, of Ubuntu, you just don't care. Maybe they run it on the big iron in the premises. Maybe they use a cheap cloud provider. You just don't care. So it's a standard way to do it. So this is a visualization of how a container looks like. It took me a while to get this because it's kind of confusing what a container really is. And the most important part is the image. In an image, it can be compared to an ISO, a DVD, a live Linux distribution, where you put all your libraries of your binaries, and when you bring that up, you always get a fresh environment. Every change you make will be lost when you restart your container. So it's kind of a read-only environment that you can change on the fly, but you restart it, you lose it. That's the idea. You always start from a fresh environment. Then you need to have some runtime information, so something that you need to have a useful container. Maybe it needs some network addresses, some ports, maybe it needs some access to a file system, mount points, etc., environments, whatever. And most important for your application is the persistent data. That's something you don't put in the image, because the image you can put it on the internet, you don't care. But your configuration, your secrets, your business data, that's outside of the container, and the container has access to that. So those are the big three parts. And then if we look at this again, we realize that we still need tools to manage the runtime info, the configuration, the image creation, and there are probably tools that we already talked about. And in this case, even cpan on the server, because you're working locally, it's okay. And Docker image file is just a series of scripts, of commands that you run after a basic image of an operating system. You start with a very small down Debian or something, and then you say, add this, add that, run that. That's it. But you only do it once, and it gets stored in a kind of a binary format. It's very easy to have something very simple. You don't need to complicate stuff at that level. So everything is containerized. Everything is easy to understand, and because of that, it's also easy to implement. But if you go here, we used to have a very big radiator, a Perl application, a radio server project, when we only use Puppet. And Puppet the code was very complicated, very big. We had a lot of tests because Puppet had to manage users, had to manage packages, services, the order they run, and at the end, it configured my application. Now with a container, I just don't do that anymore because that's in an image, that's frozen. The only thing I have to do, I have to care about my application. So Puppet now just take files, you put it in a directory, take a template, inject some secret, and that's it. So my code is very easy to read, very easy to understand, because I don't have to look at the full picture. I only have to look at my application. So we did already that. So what does Docker bring to the table? Kind of summary of what I said is efficient, because there's only one process running. It's running on the kernel. So the kernel Marian talked about, it has some C group to give you some basic security, but it's on the same kernel. It's not about emulation. Also, the way of working is very efficient because you are working on the real thing. So you save a lot of time. You don't go back and forth with the sysadmins talking about what's different. It's portable. Like I said, you can distribute your images. And it's also embeddable. I cannot read that, so I will say embeddable. That means that you, as a Perl guy or girl, you can create a base Perl image, have a very up-to-date Perl, a very secure Perl. You can provide a base set of images, of modules, excuse me, that you vetted the version, you tested them, and then someone can take your image in your company or someone from the internet and just care about their application. They just add a layer on your image, they create a new image for their application. So you're responsible for the Perl part, and they are only responsible for the application. So it's very easy to have a secure baseline that you can update, and they don't need all the knowledge for that. So I only have 5 minutes, so I will warn you. So I don't want to sell you stuff. I don't want to be only positive. So I know, do you know the first rule about Docker? I know someone here. So you won't shut up about Docker. So it's okay to give a presentation, but don't do it at the dinner table because you get very annoying. I've been there, so don't do that. So more seriously, when you use Docker, you need to test. It's not that straightforward as it looks. Yes, things are easier, things are simpler, but a lot of corner cases. You need to ask yourself some very good questions, something that you always need to do, but now you're forced to do it. You need to ask yourself, is my application horizontally scalable? If the answer is no, you need to re-architecture your application, or you just don't bother with Docker. Because Docker uses the concept of cattle. Docker doesn't care about your service, doesn't care about your container. If you have a resource problem, you just pop up some new one. So if your application is bound by CPU of memory, maybe that's not a good solution. Is your application performant in Docker? I already said it's very efficient, but there are some trade-offs on the level of networking, on the level of disk I/O. And because if your application is horizontally scalable, it's not that important, but still you need to test, you need to make sure that you make the right choices. Because on network, there are some implications on security, on flexibility, so there are choices that you need to make, and you make sure that you make these choices, and you just don't use the default of your distribution, because it's just a very generic setup. This is the most important thing I would say today. Docker is not a security solution. For most people that work with Docker, they think there is. It gives you a very dangerous, false sense of security, because you think it's containerized, I'm safe. You're not. You need to follow best practices, you need to follow common sense, you need to test, you need to make your application update. Of course, it's an extra layer of interaction, that's a good thing, but it's not enough. So if you get into Docker, most books, most talks don't go into that, you need to look into that. I don't have the time to go in detail, but with a very base minimum effort, you can get a very secure application, but you need to really be proactive about that. This is also about people, about politics. This is not a technical issue, but most companies, institutions are kind of divided, operations and developers. And if you start with Docker, you get a lot of people that will have something to say about your image. You have a lot of chefs in the kitchen, so you need to be ready for that too. You need to have a good collaboration with other teams. You need to be able to acknowledge input, to talk about it. And this also gives an opportunity. I already talked about the base Perl image. It's a very good opportunity for a Perl person to create a standard, to be the one that is knowledgeable about Perl, someone that can create a baseline, someone that can make sure that the security is followed, and so on. I have some slides left, but I'm just going to leave it at that. So maybe if there are some questions, I don't know, I can. So. Yeah, go ahead. Sorry?
Can you suggest to use Docker on developer machine?
Yeah, certainly. I will. The idea behind it is to have the real thing on your laptop. So you are working on the real thing that will run on production. So I couldn't develop otherwise, because otherwise you will always have trouble with discussion with it works on my laptop, it doesn't work on production. 1 minute. So.
Can you compare shortly Docker to other container?
Not in 1 minute. Okay. So I would say Docker is easy because there's a lot of integration already. So that makes it easy, but there are other good alternatives as well. So it's. I think I'm going to wrap it like that. Thank you very much.